Hello, it's Scott Manley here with episode 87 of Interstellar Quest. And, well, we are continuing to quest. We have Lars Kerman in control of the asteroid redirect vehicle, which has been turned into a capsule capture vehicle so that it can capture Lambert Kerman's rogue capsule and bring it back into orbit around Kerbal and of course bring it to the isolation slash quarantine slash investigation facility that we have attached to Space Lab 1. Now you might notice that the animations here are going even faster than my usual high speed animations. I now have access to up to 12 times time acceleration using an updated version of Sony Vegas, so that proved to be quite useful given that this takes a ridiculous amount of time. In fact, I think it took 2 hours of, wall clock time gameplay to actually put this thing into a rendezvous trajectory with the Space Lab, mostly because the thing could only get a limited amount of power from its beamed power antenna, and so you have to slowly adjust its orbit. And I was adjusting at all the way through the orbit, not just at periaps and apoaps. I was bringing it down very carefully all the time because I just wanted to maximize the amount of time. Of course, it's 4 times time acceleration times 4 times video time acceleration times an extra 300% time acceleration that I can get from my velocity envelope. People ask all the time, what do I use for my video encoding? And I use something called Sony Vegas, and I just upgraded from the consumer version to the professional version, and the professional version adds a whole bunch of extra features. It also adds about $300 of extra cost, but I figure that since I'm making a lot of videos, I should probably have the easiest thing I can use. I thought about using Premiere, but I don't like the fact that Adobe really only makes that available to rent these days. I have access to Final Cut Pro, which is very nice when I'm working on my Mac, but I didn't want to have to copy all my stuff onto my Mac just to edit videos. So that's what I've got right now, if you're wondering. Oh yeah, and for video capture, I use Bandicam, which has to capture motion JPEG images. So yeah, can you imagine if I had shown this entire thing, the entire 10-15 minutes worth of me just working my way through this rendezvous? I would have run out of things to talk about, wouldn't I? But instead I found myself talking about my video encoding pipeline. But thankfully this doesn't take forever for you guys, because you get to watch it at full speed, including taking 1.21 gigawatts, bringing it into an encounter orbit with Space Lab 1, at least in a few hours. In the meantime, we have another spacecraft to capture. The Duna Express is last seen expressing itself away from Kerbal at about 3 kilometers per second, so we need a fast spacecraft to catch it. So this is something I threw together using a bunch of parts which I've had for a while. It is of course all powered by a deuterium-tritium thruster down the bottom, which is bathing the entire space center in deadly levels of radiation. Thankfully, the atmosphere will block most of the radiation. Anyway, this is powered by a 2.5 meter fusion reactor with, again, deuterium-tritium reaction, and a power generator. Now, I hadn't realized this, through various testing, but I hadn't realized that the power plant had direct conversion mode and solid state mode, and you have to right click and switch between those in the vehicle assembly building. Now the direct conversion mode is supposedly more high tech, but it was returning way lower levels of power output in the end. Switching it back to the solid state, it suddenly gave me more than 2.5 gigawatts, which is great because that's what I need to make this thing run. So I could ditch those cumbersome 3.5 meter power plants and replace it with one of these 2.5 meter versions, giving me the thrust to mass ratio to enable me to escape the atmosphere and more. Yes, even with that tiny fuel tank on the back, just set up to carry liquid fuel, this thing will have something like 15 kilometers per second of delta V at maximum thrust. And of course, the lower the thrust you use, the higher specific impulse. So the way this works is the fusion reaction is going on at the same rate, but with less fuel flowing through it. It reaches a higher temperature, and the fuel is therefore expelled at higher velocities. Basic rocket physics tells you that the specific impulse of an exhaust gases is proportional to the square root of the temperature divided by the molecular mass. So if you double the temperature, then you get roughly 40% more specific impulse. So if you half the fuel, then you're putting the same amount of energy into half the fuel mass, which means your temperature is twice as high, which means you'll get 40% more fuel efficiency. Isn't that great? So yeah, you can see that Gilmore and Admin Kerman have zipped around the back of the planet, and they are of course heading straight towards this target. I targeted the object even though it was in deep space. That gave me an approximate velocity vector, and I'm more or less pointing myself along that in the hope that I will head off in the right direction at some point. The game still has some odd bugs in regards to the relative velocity vectors, so I'm going to have to get into deep space first, and you see I'm just basically pointing the spacecraft roughly where I think it should be and then accelerating towards it, and it tells me that the close encounter will be 100,000 kilometers. But of course I time accelerate out beyond the limits of the moon and Minmus and into deep space, and now I can actually switch to target velocity mode and start to correct these things, start to bring me closer to the target, so I'll fly by and be able to rendezvous with it, at least rendezvous with it in a day or so. In between then and now, I will of course have to complete the rendezvous with Landberg-Kerman's captured capsule. That is of course one of the more interesting things from this series, is handling and managing all the different missions in flight with all their alarm clocks. The alarm clock mod is great, and I really hope that it makes it into the game. I'd also like to see construction time become a very real part of the game. Speaking about updates, the grand plan for 0.26 has been announced. They just published a dev blog today explaining that editor overhaul is going to happen. We're going to get experience on the Kerbals, especially since that was supposed to be in 0.25. The Mark III spaceplane parts are going to be updated. We're going to get biomes everywhere, more contracts, and upgradable buildings. At least that's the plan, of course. Usual disclaimers are in place for maybe things not quite happening. But what's happening right now is Lars Kerman is preparing for his final rendezvous burn. So you see how the close approach vector moved from before to after the position. So by accelerating forwards in my orbit, I increase the duration until we actually get a close approach that is a little closer. There we go, 2.6 kilometers, that's close enough for me. We'll make final adjustments as we are on approach. The problem with this thing, of course, is you have to be very careful. Taking a look out the window there, you can see a tiny dot in the distance that is I'm chasing this dot around the orbit here. There it goes, 96 kilometers out. Now we need to start thinking about making adjustments. It looks like our orbit is inclined slightly from this target, so we start to make corrections one way or another. Of course, it would be really nice to have a display in this to show me what way or what the close approach is without mousing back and forth all the time. Obviously, we have huge amounts of delta V, so it's not a disaster if I can't figure this thing out. I mean, the only real disadvantage of this is the acceleration is so low you have to be very cautious at approaching, which as it happens is pretty much what you have to do in real life, because in real life you don't have a large amount of delta V even if you do have decent acceleration. Generally, any space rendezvous is carried out with extreme care to make sure that there's no chance of a collision until you're absolutely needing to actually make the two docking ports collide. And similarly, when spacecraft are leaving the space station, they're very, very careful to let them go in a particular orientation so that the tidal forces will start to drag the spacecraft away from it before it ends up firing its engine to drop it down back into the atmosphere. And I mean, the place they let them go is chosen to make sure that there's almost no chance of it coming back to the space station should its engine fail at any point. And also to put it in a position so that when it fires its engine, the exhaust gases do not come back and hit the space station and perhaps damage the solar panels. Because solar panels, if you think about it, are very thin. So the gases coming out of rocket engines will blow these things around like they are sails in space. That's generally not a good thing, which is why they have such long procedure reviews to make sure that this isn't going to happen. I, of course, managed to, overshoot in this case, which is a good thing because it means I'm not firing my engine directly at this fragile station. However, it does mean that I decide to use up some of my precious monopropellant fuel in that plasma thruster to decelerate me a little more quickly and make sure I don't overshoot by nearly so much. And now it's back to old me who's going to have to dock this thing. Okay, to get this thing docked, I think I'm going to need to let go of it and re-grab it with the docking port aligned along my long axis. And it's rotating, but I guess we hack his systems to make sure that he holds position. Otherwise, that would be really horrible. If he was able to continue spinning the spacecraft, he might get into trouble, actually. He could use up all his power applying rotations to this. Okay, so it's sliding away from us at a few meters per second. We've highlighted the docking port, and that doesn't make any sense at all. What the heck is going on here? I'm trying to control through the claw, but it looks to me like the docking alignment system is not giving me the claw orientation correctly. This is not the time for me to be trying to figure this thing out. I've got it aligned. I mean, the velocity is fine, but why is the dock... No, that is not making any sense. It's telling me to rotate off in that direction. Let's rotate off in this direction, see what happens. I rotate. Yeah, this is wrong. Okay, I'm just going to have to eyeball this thing. Wait a second. Yeah, it's turning me off this way. Unset that target. No. Control from here. Control from here is set. I think, yeah, the docking claw just makes like no sense. The docking alignment does not know what to do with the docking claw by the looks of things. Perhaps there's some orientation vector inside that I'm missing. Okay, so I'm just going to eyeball this thing, and using my precious RCS fuel, of which I have used a great deal in getting here. Mostly because it gave me higher thrust from the plasma engine. Okay, so that looks pretty good. It's nice to know that we have a long vehicle that has pretty good rotation indicators on it. Okay, I need to slide sideways and put my claw in the back of its heat shield. There we go. That's a view from inside. Wow, look at that. That's a pretty good view, I have to say, with the Space Lab 1 floating nearby. Now, where is the actual... The capsule is just sitting there off to the right a little. Come on, show yourself. Show yourself, you sneaky capsule. I need to grab the back off you. And we're going to pass close to the station. I hope we don't collide into it at this rate. I think we're going to miss the station, but that would be really kind of embarrassing if I had let go of the capsule and it continued and banged into the station and broke things. We are going to pass in front of the infrared telescope. Okay, there's the capsule. Now we kind of want to get as close to the middle of this heat shield as possible because we want to use... Well, I guess the docking claw is absolutely useless for guessing docking alignment, but if we can get this thing aligned up... Oh, there's the moonrise as well. Hello, moon. Good to see you poking your head above the horizon. It's always nice to watch a moonrise in space while I'm trying to grab this rogue spacecraft once again. Yeah, I'm just totally guessing my way through this and coming in fast. Oh, off to the right a little. Oh, come on, right. Down. Just a little, and come on. Oh, brilliant. Okay, I think that's aligned pretty well. Now, we need to figure out where we are. Yeah, that's... I'm not sure that's much of an improvement. Okay. Okay, now we have secured Lambert in the correct orientation. We'll just kill our relative velocity using the plasma engine. Just, chasing after that velocity vector. Obviously, I'm trying to minimize the use of my monopropellant. It's starting to run a little low. There are a handful of docking ports around that core there, and those are the ones that I'm going to go for here. Now, for just a capsule, this would be an easy target. Unfortunately, this spacecraft also has a bunch of hardware sticking out, and I don't want it to collide into the rest of the station, so I'm going to have to be very careful with my orientation on this. The good news is, however, that we don't actually need the plasma engines anymore, so we'll be able to fold all that stuff away safely. So right now I'm just rotating the spacecraft around. I want to find 2 docking ports that I can dock to. There is a docking port on this grabber, on this spacecraft. I'm not going to dock with the grabber. That's only being used to grab things which I can afford to damage. And frankly, actually, it's a good idea to damage the heat shield on Lambert's spacecraft, just in case he figures out some way to try to bring it home, perhaps. We don't want him using that to get home. So there, fold away these, close down my beamed power receivers since we don't need them anymore, fold away the radiators. That makes us narrow enough that we can actually slide into the location that we need to without perhaps damaging anything around it. For navigation purposes right now, I'm using the cockpit as my reference point. So of course I can switch inside the cockpit and see how everything's looking. Always like looking out of this cockpit. It has pretty good visibility. It kind of feels like the cabin of a crane in space. Very industrial. One of my favourite parts from B9, despite the fact that it's not really an aircraft part. It's a high-tech spaceship part. And this high-tech spaceship part is moving in at about 0.1 meters per second. I'm doing this very slowly. You see, using time acceleration to try and make this thing slightly less tedious, but we want to keep the relative velocity low simply because I'm not in a rush at this time. Once we get in close enough, we will let go of the capsule and it will hopefully continue on with its momentum and bond onto that docking port safely. And not a moment too soon, because the sun will be setting any minute now, and doing this kind of, careful operation in the dark is not the easiest thing. Okay, here we go, moving in at 0.1 meters per second. That is about 4 inches per second. About twice as fast as the space shuttle would approach Mir during its original docking plans, if I remember rightly. I think 2 inches per second was how fast this moved. Okay, getting ready to release, and as soon as I release, I will apply my retro thrusters to move me away, and hopefully the magnetic force will do the rest. And if we go, capsule detached, watch it move in towards its destiny, and it's captured. Brilliant. Okay, now the Kerbal Space Police can move Lambert into the quarantine facility, and Lars needs to dock this spacecraft because he's really run quite low on a monopropellant, and it would be very nice if he could fill up his tanks here. Also, it's a nice excuse to actually use that bottom docking node which has been added and never actually used until this time. So we have to move around to the other side of this ring of docking ports. The ones 90 degrees away are unfortunately going to end up with the spacecraft colliding with Lambert's capsule. So we need to go all the way around to the other side, pitch the spacecraft down, and by this point we are doing everything in the dark of night. It's a good thing we actually have some lighting on this spacecraft to help me navigate. It was designed to navigate in a deep space, but people think of deep space as being dark, when in fact deep space is almost always light because it's not near any planets to eclipse the sun. It's only when spacecraft are operating near planets that they really need to worry about night. And when you're operating near planets, night can happen quite a lot, like every 90 minutes if you're in Earth orbit. It's not so much night as it is a regular solar eclipse when the Earth comes between you and the sun. Anyway, with Lars about to return home for some well-earned rest, it's time for me to say, I'm Scott Manley, fly safe.